This is the post lab for limiting reactant lab. And we already did our balanced equation. We wrote out the states of matter. We have that completed. Each one of you received a different amount of substance to do. And then you completed it, you filtered it, and we weighed at the end. So we have these questions, and I'm going to break these down for you as we go through. Okay, so the first thing is I asked you to do the formula mass of copper 2 chloride dihydrate. We worked with a dihydrate. It's a little bit more stable than your copper 2 chloride by itself. And so the actual mass of what you guys were working with was actually 170. Okay. So question number 2 says, what is your limiting reactant? And so what I did over here was I went back to what my copper 2 chloride weighs. So not the hydrate, even though we use the hydrate. I chose to use the aluminum. There is a reason why I chose to use that and not the copper, but it doesn't matter. I looked at the results, and on my results, I didn't have any blue in there. And so, I'm sorry, I had blue left over, and so therefore my copper chloride was in excess. Okay, and I see this from my calculation. So this number is the number that you have to put in yourself, and you could start with aluminum if you wanted to. And so I put in my 0.25 grams of aluminum. We're all going to have 1 on the bottom. This step is the same for us as well. I have grams on top, so I got to put grams on bottom. I'm going to have mole on top. This is your new step here that we're still working on. This step comes from your balance equation, which is why you need to have it. So I look at my balance equation, and I notice that I've got 2 in front of aluminum. That's where this comes from. Then I go and look at my copper chloride, and I have a 3 here. Also why I have 3 there as well. Then I need to go and get my grams because moles mean nothing to us. So now we're back to the step that we did as a 1 step with a 1 mole of copper chloride on the bottom. And then I take what I got for my sum here, that 134 grams of copper chloride, and it goes on top. And so what I discover is I only need 1.86 grams, but I have 2 grams. So my copper chloride is in excess. Question number 3. Once I figure out who is in excess, we call this other one over here our limiting reagent. I had to run all my calculations now with my limiting reagent. So I start with my 0.25 grams of aluminum. Again, the red number represents the number that you guys will be using, whether that's aluminum or copper 2 chloride. I have aluminum on bottom, moles of aluminum on top. So same step as we did up here. Then I do my ratio. I have 2 moles of aluminum to 3 moles of copper, 2 to 3. Now I need to get back to grams of the copper, so I'll put 1 mole on the bottom, 64 grams of copper on top. Here is my math laid out for you, and this is the amount that I got. Now, I will expand this out. Let's say that you went with the copper chloride instead. So I use my copper chloride amount. Again, I'm converting it grams to moles like we've done before. I go to my balanced equation. It's 3 moles of copper chloride to 3 moles of copper. And then I do my 1 mole to 64 grams. When I do my math of the top divided by the bottom, I get 0.95 grams. Notice that with the aluminum, this number is lower than this number. This is why the aluminum is our limiting reagent. Because it produces less of the desired amount of what we're interested in. Question number 4. What is your theoretical yield of aluminum chloride? So if you had more time, what you would do is you would actually evaporate out the liquid of your solution at the end, and we would weigh your solid substance that would recrystallize at the bottom. So we take our 0.25 aluminum, because it is our limiting reagent based on my calculations. Again, our conversion here from 27 grams of aluminum to 1 mole of aluminum. My balance equation again, 2 moles of aluminum to 2 moles of aluminum chloride. And I got to switch my moles to grams. I get 1.22 grams aluminum chloride. Question number 5. What mass of the excess reactant will remain when limiting reagent is consumed? So we go back to our table, and in my table I was given 2. In question number 2, I solved and found out that I only needed 1.86 grams of copper chloride. So I'm taking the difference between these two numbers. So 2.0 minus 1.86 is 0.14. So if your solution is still blue at the end of the reaction, what was your limiting reagent? If it's still blue, then aluminum is limiting it and copper is excess, because we know that that blue is a copper indicating color. And if you cannot see blue in your flask at the end of reaction, can you be certain about which reactant was limiting? Not exactly. The blue might not be distinguishable, so also look for excess foil in your filter paper to help make the determination. If you have no excess foil in your filter paper and it looks clear, you can probably conclude at that point that your copper chloride limited the reaction. So think carefully about your limiting and excess reactants and the products you have formed. Which of the two products would you isolate and calculate percent of yield for? I'm leaving this open to you, but I will say, hopefully most of you figured out that we can get the copper and any other solid material out on the filter paper. Some of you were actually having to pick out your aluminum foil and spray that off because you had excess aluminum foil. And then the AlCl3, we would need more time. We'd evaporate the water off and then weigh the contents at the end to see what we ended up with. Number 9, which did you isolate? So this is up to you. You have to tell me. Okay, so that's open to you. Most of you all have filters, so that's how you're isolating your copper. Calculate percent yield. So we have a formula, percent yield formula, which is actual over theoretical times 100%. It is also mathematically part over whole times 100. So our actual is what we measured at the end after we did our weighing paper. So for me, I got 0.56 grams. If I go back to question number 3, I calculated that I would, by this reaction, produce, in theory, 0.89 grams. So I'm simply going to take the actual that I weighed on the filter paper minus the filter paper, 0.56, divided by 0.89 times 100, and that equals approximately 62.92%. So is your percent yield reasonable? Again, this is for you to work out, okay? We've mentioned before, we shouldn't get over 100%, okay? If yours is over 100%, not quite reasonable, okay? If yours is less than 100%, I would say you did pretty good, but also support it with evidence. Did your filter paper, was it only copper all the way through, or did it have some other color? Was there aluminum foil in there? That kind of stuff. So think about that as you give me your reasoning with your evidence. Then, don't forget to do your standard 5 as always. Make sure you write those in complete sentences and start strong. Don't say how, what, why, or when. Explain to me what you learned. Final thoughts. Finding limiting reagent. These are also available to you on your PowerPoint. And this is just stepping you through some of the calculations of how we figure out which limiting reagent is. Then this also goes back to the law of conservation of mass. We can't create more than what we started with, which is why I say you can't have more than 100%. Law of conservation of mass, whatever I start with, I end with. Then these are just some different reactions with your copper. I also going back over your redox as well. These are some stuff I'm front loading as well. Okay, So we talked about redox, about your gaining and losing electrons. This is another one. We've done this as well with the copper and the silver nitrate. So you've done these reactions, and here is your reaction here. I've not had you do aluminum copper nitrate or tin and copper nitrate. And this is pointing out that our reaction that we're seeing is based on the strength of that metal that you're working with. And so based on where your metal is on this chart will determine how active it is in different situations. So food for thought. And then we're going to be talking about empirical molecular formulas soon. Empirical is your simplest form of a formula, just like we see here. And the molecular formula is the actual formula. So a molecular formula is always a multiplier of the empirical formula. And we're going to learn how to actually calculate that and determine that. So just front loading here, empirical formula. We're going to learn how to do the calculations where we're going to take our measurements and convert them over to moles and find the mole-to-mole ratio between each one of these. And then percent error is another calculation we've worked on in the fall. Again, just a review over that. Sometimes I need to find out how off I am from the accepted value. And so this is how I find out how off I am from what was accepted. And then this is your percent yield. Yes, again. So again, this is the one we are using in this lab with the actual over theoretical. Actual is what you actually do in lab versus theoretical times 100. And then hydrate versus anhydrous. You've seen this with the copper sulfate. Copper sulfate pentahydrate is blue. And then when you guys see hydrate, you just had copper sulfate. So hydrate just means I have water attached to that. And these are extra notes going back over mole-to-mole ratio, reminding you about your balance equations. That balance equation is a mole-to-mole ratio. And then how we find mole-to-mole from empirical formulas. Anyway, I hope you got something out of this lab. And solubility, we also forgot to mention that because some things are more soluble than others. And we saw that the aluminum is soluble. Okay. And review our chemical equations, reactants, and products. Because again, we're working on that vocab. We'll make sure we have it down. Balancing chemical equations, our rules for that. Every day you get stronger. And then our periodic table. And all that information that we've learned, you've got to know. Okay? Properties, physical, chemical changes. All right, that's your lab this week. Live long and prosper.